6.1, radian measure. Previously we talked about the measure of angles as being degrees. When we were talking about the trigonometric functions, I mentioned to be careful to make sure your calculator is in the right units. Degrees, radians, and gradients being the possibilities. In the past we used degrees. Today we're going to talk about radians and what exactly a radian is. We can see radian. So what is it? Well, I'm going to start by drawing our axes, and then I'm going to attempt to draw something that looks somewhat like a circle on those axes. The distance from the center of a circle to any point on the circle is the radius, and I'm going to use r for radius. The diameter of a circle is 2r. Now, if I was to draw another radius, say about here, obviously that length would also be r, the radius. There would be an angle theta in between them. And if this arc from here to here has the same length r, then the measure of this angle is 1 radian. So 1 radian is the angle necessary to create an arc of length r, or an arc that is the length of the radius of a circle. Now many times we use s for the length of an arc on a circle, but right now we're specifying that this is basically a pi piece that has two sides that are length r, and the arc between them is also length r. So that's 1 radian, the angle that creates that. So if we were to go 2r around the circle, that would be 2 radians. If we were to go 3r around the circle, 3 radians, etc. And if we were to go all the way around the circle, we would find out that that is 2 pi radians. Now we know that a full circle is 360 degrees, so we can say that 360 degrees is equal to 2 pi radians. Knowing this, we can create a ratio to convert between degrees and radians. So if 360 degrees is 2 pi radians, then 180 degrees is pi radians, which means I can now create ratios. I can say 180 degrees over pi radians, or I can say pi radians over 180 degrees. And that would be my conversion factor. If I want to convert from degrees to radians, degrees multiplied by pi radians over 180 degrees, the degrees cancel out and you're left with radians. If I want to convert from radians to degrees, however many radians multiplied by 180 degrees over pi radians, the radians cancel out and I'm left with degrees. So let's give this a shot. "27 degrees is how many radians?" So we take 27 degrees times, we want to turn this into radians, so we're going to take pi radians over 180 degrees. Let me grab my calculator. I mean, we can obviously say that this is going to be 27 over 180 pi, or 27 pi over 180. We could actually 27 and 180 are both divisible by 9. So I have 3 over 20, or 3 pi over 20 radians. So no calculator necessary if I want to get an exact value. 3 pi over 20 radians. Well, let me just make a note at this point that when we're talking about radians and degrees, if we're talking about degrees, we have to put the degree symbol there. If we're talking about radians, let's just make the agreement right now that you don't have to put rad or radians there. If you have an angle measure that is in radians, you can just give the measure. So if I ask for the sine of 42 degrees, that's in degrees. If I ask for the cosine of 1.8, since it does not have degrees, then it's assumed to be radians. Well, let's convert the other direction. What if I have something in radians and I want to turn it into degrees? So I have 2.3 radians, and I want to determine what that is in degrees. Well, if I'm in radians and I want to get to degrees, I'm going to multiply by 180 degrees over pi radians. So 2.3 times 180 degrees over pi. Remember, I don't have to put radians in there because it doesn't have a unit, so it's assumed that it's radians. So 2.3 times 180, 414. So 414 over pi degrees. Now, I don't like having pi in the denominator. I could leave it there and that would be an exact answer, but I don't really like having pi in the denominator, so I'm going to divide by pi. And that gives me approximately 131.78 degrees. And I'll be honest with you, when you're writing angle measures in radians, it is perfectly allowable to leave it in terms of pi unless you really need to specify a numerical value. Whereas if you're dealing with degrees, it's really not considered to be appropriate to leave it in terms of pi. So just to put that out there and make that clear. So that's how we can convert back and forth between radians and degrees. But now we're going to get a little fancy. And we're going to find all the radian equivalents of the angles that are of quadrantal angles and our standard angles, and all of the angles that have those standard angles as reference angles. So that means 0, 30, 45, 60, 90, 90, 120, 135, 150, etc., 180, etc. So we're going to get all the equivalents. So if I'm going to do that, let's start out with my put a unit circle here. And I can start and say, okay, I know the beginning point is 0 degrees. 0 degrees is 0 radians. So that was easy. 0 radians. Okay. I know that 2 pi is 360 degrees. So I could say 360 degrees is equal to 2 pi. And I'm not going to put the radians in there just because it saves me having to write it. Okay? I'm going to get rid of my calculator, I'm not going to need it. So if 360 degrees is 2 pi radians, then 180 degrees is pi radians. If 180 degrees is pi radians, then 90 degrees is pi over 2 radians. If 90 degrees is pi over 2 radians, then 45 degrees is half of that, so pi over 4 radians. If 90 degrees is pi over 2 radians, 1/3 of that is 30 degrees. So 1/3 of pi over 2 is pi over 6. Double 30 is 60. Pi over 6 times 2 is 2 pi over 6, or pi over 3. So now that we have these, we can really go around and do everything else. 90 is pi over 2, plus 90 is 2 pi over 2, or pi, plus 90 is 3 pi over 2, so 270 degrees is 3 pi over 2, and plus another 90 degrees is 4 pi over 2, or 2 pi. 45 degrees is pi over 4, 90 degrees is 2 pi over 4, or pi over 2, 135 degrees, so pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, being pi, 5 pi over 4, 180 plus 45 is 225 degrees, 6 pi over 4, 7 pi over 4, 270 plus 45 is 315. So now I have all those, I have my quadrantals, I have all my 90, my 45 and 90, or I should say any that have a 45 degree angle reference angle. So now 30 is pi over 6, 60 is 2 pi over 6, or pi over 3, 90 is 3 pi over 6, or pi over 2, 120 is 4 pi over 6, or 2 pi over 3, 150 4 pi over 3, 5 pi over 3, 6 pi over 3, sorry, I said that wrong, 2 pi over 3, sorry, 4 pi over 6, 5 pi over 6, there we go, and then 6 pi over 6, which is pi, 7 pi over 6, 210 degrees, 8 pi over 6, 240 degrees, and 8 pi over 6 is 4 pi over 3, 9 pi over 6, or 3 pi over 2, 10 pi over 6, or 5 pi over 3, which is 300 degrees, 11 pi over 6, which is 330 degrees, 12 pi over 6, or 2 pi, 360 degrees. So we're able to create all of these angles and do the conversions. So technically, you should be able to find any radian measure for all of our quadrantal angles and for our standard angles just by starting out with the fact that we know 360 degrees is 2 pi radians. Now that we've gone through that, I will point out that you can have a unit circle or a drawing of a unit circle that includes all of these degree and radian measures and the points on the unit circle, which give you your sine, your x and y, or your cosine and sine values for any of these angles. And if you look in the exams section of Blackboard, you will find there is an image there with that unit circle. And you may use that on exams for homework, whatever you like. You may keep that with you, have it as an image on your phone to enjoy at random moments of the day and night. Okay. And it's very helpful. It definitely simplifies a lot of things, just be able to quickly look it up. But you should be able to do conversions back and forth between radians and degrees. And I would hope that you would be able to work your way around the circle and create each of these values just as I did, without a calculator, just using that basic knowledge that there's 360 degrees in a circle and there's 2 pi radians in a circle. If you can remember nothing else, remember those two things. Okay. Now we're going to talk about arc length. Remember a little earlier I mentioned that the arc length you usually say is S. So if we have a circle-ish type thing, and we have an angle theta, a radius r, then that arc length is S. Now, given any two of these, the angle in radians, the radius, and or the arc length, so any two of these, we should be able to find the other one by simply using the formula S, the arc length, is equal to r theta. Now you may ask, well, Mr. Davis, how can I remember that? Well, let's put it this way. What is the circumference of a circle? The circumference of a circle, C, is 2 pi r. How many radians are there in a circle? If I go all the way around, how many radians? Theta is equal to 2 pi in this case, right? We went all the way around the circle. So C is equal to 2 pi r, where 2 pi is the theta, the angle of measure that we went around. We went around the full circle. So now we can see that that's very simple. The arc length, if the theta is 2 pi, is the full circumference. Circumference is equal to 2 pi r. So for me, that's a way that I can remember it, because I can always remember 2 pi r for the circumference because we've done it so long since grade school. So now I can look back at that and say, well, wait a second, well, if that's 2 pi r, theta is equal to 2 pi r is going to give me the circumference of the circle. So we can do that. So what if I have a circle with radius of 5 centimeters and we go 1.6 radians around that circle? What is the length of the arc? Well, it's simply 5 times 1.6. So 5 times 1.6. 1 times 5 is 5. 0.6 times 5 is 3. So 8 centimeters. So we're able to find the length of this arc, S. Now we could work any other way and say if I was given the arc length and the radius, what's the angle? Just fill in those two and solve for the angle. I will point out, just to make this clear, that this S equal to R theta, theta must be in radians. Okay, so our angle must be in radians. If it is not in radians, then you need to convert it to radians. It does not work if theta is in degrees. So, and why is that? Well, that's because radians is based on the radius. That's what this is all about. You're saying how many radiuses does it go around? Well, if 1 radian makes it move 1 radius, then this has to be in radians. That's just telling you, boom, we got that, we have that, right? 1 radian would make it R, 1 radius. 2 radians would make it 2 radius, or 2R. Another thing that we can do, I'm going to get rid of this part, is we can find the area of this sector. So I'm going to put that as a sector. Okay? The area of the sector is equal to one half R squared theta. Okay, 1/2 R squared theta. Well, where did I get that one from? Well, what is the area of a circle? It's pi R squared, right? So if the area of a circle is pi R squared, I know that the number of radians covered is 2 pi. So if I came out with pi here, and the number of radians was 2 pi, then this must be theta divided by 2. Right? I know my angle is 2 pi to go all the way around the circle. So if that gave me pi here, then I must be taking theta and dividing it by 2. 2 pi divided by 2 gives me pi. Theta divided by 2 times R squared. So based off the same formula, we could actually say that this formula is based off of that one. So now give me the radius and the angle in radians. Just going to put that down again. And we can get the area. If R is equal to 1.2 pi radians, and theta, actually, why am I doing that? I want theta equal to 1.2 pi radians, and R is equal to 7.6 inches. Let's find the area of the sector. We just say area of the sector is equal to 1/2 times R squared, so 7.6 squared, times 1.2 pi is equal to, and for this I'm going to pull out my calculator. We have an area, I don't really care to have it in terms of pi. Especially considering we're dealing like inches. You wouldn't say such and such pi inches. So I'm going to actually go through the calculation. So I have 1/2, 7.6 squared, which is 57.76. So let's make it 1/2 times 57.76 times, and I'm going to find out what 1.2 pi is approximately. 1.2 times pi gives me approximately 3.77. So if I multiply those together, I get 108.875 inches squared. Remember, areas are always square in units squared. So I just plugged it in. Again, we can do the same thing anyway. Give me the area and the angle, and I can give you the radius. Give me the radius in the area, I can give you the angle. Give me the radius and the angle, and I can give you the area. Just remember that for both of these formulas, theta must be in radians. And believe it or not, that finishes up 6.1 radian measure.